Hello Python programmers. So in this video, I'm going to show you that how you can create a Python program to auto blur the human face using OpenCV Python. So let me first show you that what I mean by auto blurring or whatever I have said. Okay. So here we go. And let me run this. And here you can see, hi, this is me. And you can see that there is a green square around my face and it is blurring my face. If I put a hand in there between, here you can see my face now, and now you can't. Now you can, now you can't. Okay, so this is the program that we are going to create and we'll be using OpenCV Python. So if you haven't installed Python, then what are you doing in this video? Just go to python.org and install Python. And if you haven't installed OpenCV, then open the command prompt and just write pip install, I guess it was OpenCV Python or Python OpenCV, I'm confused. So yeah, it was OpenCV Python, and click enter and this package will be installed for you. So enough of talking, now let's go back to our editor so that we can start writing our code. Okay, so now we are into our editor. So the first thing that we need to do is we need to import the OpenCV library of Python and time. We'll be using time to basically close the GUI which will show us the image. I'll show you in the video itself and why I'm not able to write import. Okay, so we'll import CV2 and we'll also import time. So let's import them together. Okay, now we need to call, or we need to load the face cascade. Now for all those who are new to this video, this is a OpenCV project series in which we have discussed many projects like cat face detection and using the mobile camera to do face detection, and face detection using the webcam, and face detection using the ESP32 Wi-Fi module. So this is the continuation video, and the people who have watched our previous video already know that how face recognition works. So if you want a detailed explanation of face recognition, I'll recommend a video below. Although I'll explain you what face recognition is in this video also, but that video is more detailed. Okay. Okay, so now we have loaded our har cascade. Now this XML file contains the feature data. Here we are using the har cascade or the cascade file for frontal face. We have the same for cars, for nose, for eyes. These files just contain the data so that we can compare it to the live data coming from our webcam or any of the source, and then we can say that whether that feature is present in our video or not. And in our case, the feature is the human face. Okay, now one thing I want to say before I move ahead. Now I have seen a lot of comments in my video where people just copy paste the error that they are having and they are not at all even trying to search that error or even read that error, because that error clearly shouts and screams that this is the error, corrected. And sometimes I've seen that people are commenting the spelling error. So read the comment first. I'm not saying don't ask questions, but ask questions that are genuine. Okay, so Python is case sensitive. So here the C in cascade and the C in classifier are capital. I'm focusing this because I know if I don't focus, there will be a person in below asking that I'm having the error. Python is saying cascade is not recognized. Okay, so I'm saying this beforehand only. And if I see a comment like this below, I won't answer that. Okay, now let's create the variable which will record the input from our webcam. Now you can use your external camera, you can use your mobile camera, or you can even use an ESP32 Wi-Fi camera. I have created video for all of that. The link will be provided below, but here we are gonna keep things very simple, we'll be using our laptop webcam. So we'll write video capture, and then the input here is 0, which is the default value for our webcam. Now let's create the while loop so that we can extract the video. Now this is pretty much understood that this video variable will click still pictures. So what we are doing here is we are creating a while loop and then creating a slideshow of images, and that slideshow of image is called a video. This is why we call frame per second. It defines the frames that you will see per second. Okay, you must have heard all the gamers say and all the brands say that the FPS is high. It means that the frames per second or the still images coming to the screen per second is high. Okay, so fact for the day. Okay, so now let's create two variables. First is actually, yeah, so we'll create two variables. First is check and second is frame. So we'll create a video dot read function so that we can read the data or the image data which is present in our video variable, which is taking the data from our webcam here and then storing this into this frame variable. Okay, now what we'll do is we'll convert this colored image. As you can see that the image from the webcam is colored, so we'll convert this colored image into grayscale image. Now why we are doing so? Why we are converting the colored image to gray? So grayscale image is much easier and much accurate for feature scaling. The features are much more easier to catch. Now this is very simple concept because in color image we'll be having many colors and many shades of color, but in black and white image we'll be having only two colors, black and white, and their shades. So the feature detection will be easy. Pretty simple. Okay. Okay, so now I guess this is pretty much understood here. We are using the CVT color function, and first parameter is the frame having all the values of the video which is coming from our webcam, and then we are using cv2.color bgr, which is blue, green, red, to it should be 2 here. Okay, to gray, simple. And now as we have extracted we have converted our colored image into grayscale, let's find out whether there is a face in our image or not. So how will we do that? So what we'll do is we'll compare this image which is coming from our webcam to the face cascade, to the cascade provided to us by the OpenCV, which is having the possible features of a face. So this is a XML file of data which is created using machine learning, having the output of multiple sample of human faces. Okay, I won't go deep into that. So let's continue. Okay, so now we have used our detect multi-scale function, and then we are saying to Python, okay, so this is the face cascade variable having all the data from our frontal face XML file. Apply this to this grayscale image and use these parameters. Now I won't go deep into these parameters, just understand them. They are meant for detailing in the feature detection. I have explained these parameters in one of my previous video. Okay, I'll provide the link below. Now the input in this face variable are 4 values. First is the x and y coordinate of the face. Let's say that my face is present on the screen, right? And at this point my face starts, right? This is my face, this square, my screen, where my mouse is going, this is my face, and from here my face starts. So the first value will be x coordinate, and the second value will be the y coordinate. Okay, the third value will be the height. So like this is the height of my face, and the fourth variable will be the width. Okay, so now by using this data you can do anything of your face, because you're having the starting and the height and width. So even the 6th class math student would say that you can do anything with these data. Okay, so now let's move ahead and let's use a for loop and use these four data, x, y, and let's say width and height in our face variable. I guess it's face, yeah, in our face variable. And then first what we'll do is we'll draw a rectangle on our face. So what we'll do is we'll write cv2 dot rectangle, and the first parameter is frame. The second parameter is x and y coordinate, the starting x and y coordinate. It should be x and y, just a second. Yeah, x and y. And then we have x plus w, which is the width, and y plus height. Okay, so we are like drawing the two planes, the first two planes, this one and this one, so that we can just replicate that and create the rectangle. Okay, the height and width of the rectangle we are having. Okay, then we'll specify that what will be the color of the rectangle. So let's say that we want this to be green, so RGB. If you want this to be in red, you can write 255 here. If you want this to be green, you can write 255 here. And if you want this to be blue, you can write 255 here, or you can mix the color. Now, the last parameter is the width of the borders. How thick will the borders be? So let's make it 1, very small. Now comes the main thing. All the code that we have written above, we have already discussed in our previous videos, but this part is gonna be new, because we are gonna use the median blur function from OpenCV to blur our image. So what we'll do is we'll extract the y is equal to y plus h and x is equal to x plus w. So the height and width, the extent this blur will go, and then we'll use cv2 dot median blur. Now there are many options present that you can use to blur an image, but I'm using median blur because it's simple. And there are many like Gaussian and many others. I'll provide the link below. Okay, you can read from there. And then the first parameter is the image, and then the same thing we'll do here, because we want to define that on which portion we want to do the blur. If we don't define this, all the image will be blurred. I'll show you that how that will also happen. And then we'll define the percentage of the blur. Now you have to mind one fact, that it should be a positive number and it should be an odd number. So let's say that I want to blur this by 35%. So what this median blur function will do is it will find out the median of all the pixels, like all the pixels present on my face. It will median that and then provide 3500% of noise and then just display that. So our task is done. Let's use cv2.imshow so that we can use our Kinta GUI to display the image. Yes, cv2 uses let's say gotcha. This is the thing that I like to use. Yep. And then the thing that we want to display is frame. Now you don't want to display the image, you want to display the frame. The frame is having the whole image and the image is only having my face. Okay, so we want to display the frame. So we'll specify the key value, the key variable, so that we can close our Kinta GUI. So we'll write wait key for 1, and actually I guess this K should be capital, I guess. And yeah, if the key is equal to order of Q, because we want to close the GUI as soon as we print we press the button Q. So we'll simply break this, and now let's video dot release and cv2 dot destroy all. I guess this A should be capital. Destroy all windows. Now you have to make sure that you're writing the right spellings. You're writing things in capital or in small as the language suggests you to do, because Python is case sensitive. You know that. Let's run this program and let's see whether it's working or not. And it seems like it is having some error. Let me run this again. So it's taking a bit of time, and yes, we are having an error. So what is the error? And okay, frame cv2 dot color bgr. Okay, just wait a second. Okay, so I have to pause the video because I don't know why that error was popping out. Yeah, this is a genuine error because I am writing the wrong spelling. It is min neighbors, and this is what I am talking about. You have to see what the error is, because Python shouts that what is that error, and you have to listen to it. Like, yes, there is no cv2.cv2 has no attribute as median error. There is a sure spelling mistake, right? This is capital B, and this is how you find out that what that error is. You read the exception that what it is saying. So just read it, and now it was working, but it's showing an error. So let's read that again. Q is not defined because it should be inside a string. Actually, it should be a string. It should be not inside a string. It should be a string. So yeah, let's see whether we are having an. So nope, we are not having any error. Our program is working fine, and as you can see, my program is blurring my face. Okay, so yep, our code is working fine, and let's play along with this code a little bit. Okay, so let me close this. And as I've told you, what if we decrease the value of this blur? Let's make it 5. So the intensity of the blur will decrease, and you will see the intensity of decreasing of blur. Here you can see there is not at all decrease in the image quality. There is a slight bit of decrease in image quality. Okay, so let's close this and let's make it 35 only, and let's see that what will happen if we remove these values. Right, we remove these values and we just save and run it. So the whole image will be blurred because this is applied to the whole. Actually, it's not blurred, you know, it's not blurred. Just let me check. So yeah, let me so actually we are not applying this blur to any portion. So how will that blur occur? So bummer. Now let's see what will happen if we replace this frame with image. Now only my face will appear. Spoiler. So here you can see, I guess, the whole image. So why it is happening like this? Why it is happening like this? So yeah, the frame is still when the program was not able to get the face. So yeah, this program is only working until and unless it is getting a frame. So I am playing a song like this. Okay, so yeah, the right code was to use frame here, and I was just having some fun with playing along with the code. And this is what you should do also. You should always play along with the code and see that what possibilities are there, what values can be changed, and what will happen if we change a certain value. So yeah, you should do that. Okay, so this is it. This was a short video in which I have shown you that how you can create a Python program to blur the human face. Okay, so meet you in my next lecture. Bye bye.